Next, let us go to the most important point of the vector algebra, that position vector of a point. Actually, what do you mean by position vector of point? Just like in 2D coordinate plane, as we have x-axis and y-axis, as this plane is divided into 4 equal parts, each called as quadrant, and we call x dash ox and y dash oy. In this coordinate plane, every point is designated by means of coordinate, or we call it as ordered pair. As every point in this Cartesian plane is designated by means of ordered pair, even origin is also given as 0, 0. In 3-dimensional geometry too, we have the coordinate system with x dash 0 x, and we have y dash 0 y, and this is z dash 0 z. In this Cartesian plane also, every point is designed by means of ordered triad. Every point is given by means of coordinates, what you call them as ordered triad, including the origin. Here, ordered pair. Every point is given in terms of ordered pair. As it happens, then in space also, in vectors, we designate or we denote every point by using a vector, which you call them as position vector. Position vector is a vector which will be used to denote every point in the space. In this animation, you can observe that origin and point P, origin and point B, and origin and point A. So this point A, point B, point P are denoted by means of these vectors, which you call them as position vectors. This is usually denoted by OA bar, that is equal to say A bar. This is usually denoted by OB bar, that is equals to B bar. This is usually denoted by OP bar, that is equals to P bar. So we define the position vector of a point as the vector whose magnitude is as the distance of the point from origin, and the direction is from origin to that point, is called as the position vector of that point. So we define the position vector of any point as the vector whose magnitude as the distance of the point from the origin, and the direction is from origin to that point, is called the position vector of that point. For example, instead of that point, if I can take a point, say instead of that point, then it's called position vector of that point. Now if I make the definition this way, the vector whose magnitude as the distance of point A from origin, and the direction is from origin to the point A, is called as the position vector of point A, and this is usually denoted as OA bar. That is nothing but position vector of point A. Similarly, the position vector of point B is denoted by means of OB bar, that is position vector of point B. Similarly, the position vector of point P is denoted as OP bar, implies this is position vector of point P. Like that, even you can find position vector of point origin, that is OO bar, that is position vector of the origin. So this, its position vector also designated by means of 0, 0 bar, that is null vector. So it is a good example for null vector, that the position vector of the origin as null vector. After this, next we'll observe this animation related to the resolution of vectors in the 3 rectangular resolution. So this is x, y and z axis, where you will have a point P, which is in the octant. Earlier in 3-dimensional geometry we have discussed. This is a figure related to this concept. See, we'll discuss the resolution of vectors in rectangular Cartesian system. How do we represent the vectors in the rectangular Cartesian system actually? As we had in 3-dimensional geometry, that there are x dash ox and y dash oy and z dash oz. These are the mutually perpendicular lines, frame the space into total 8 parts, and each part is called as octant. This is the history. When this octant contains all the points, a point in it is denoted by means of ordered triad, say we take this point P is denoted by means of x1, y1 and z1. Point P, x1, y1 and z1, where this here you can have x1 gives you the distance of the point P from this space YOZ plane. Y1 gives the distance of the same point from ZOX, and Z1 will give you the distance of the point from XOY. That is how you denote a point. But just now we had the position vector of point P, which is given as OP bar. What is that one is when origin is taken from origin to this point P, it is like there is connection in the form of in literally meaning like a thread like structure, and this is usually denoted by vector R bar, which gives you the general vector OP bar. And as P is given by means of a variable point x1, y1, z1, and as to make this Cartesian system to represent or resolution of rectangular Cartesian system of vectors, let us take the directions for this coordinate system. So let us take I bar and j bar and k bar, which you call them as unit vectors, along OX bar and OY bar and OZ bar respectively. So the contents are taken the directions I bar and j bar and k bar. Hence, say this one, what we had I, j, k, the directions along x, y and z. Now this Cartesian system enables, so O, X, Y, Z, this is a rectangular Cartesian system in which OX is not axis OX bar, along with we have OX into I, and OY bar is along with OY into j, and OZ bar is along OZ into k bar. I bar, j bar, k bar are unit vectors. I bar and j bar and k bar are unit vectors which are orthogonal, that is mutually perpendicular. Hence this represents every point in terms of a vector with components. In the beginning of the theory part we discussed that A bar is given in terms of the component like A1, A2, A3 means A1 stands for X component, that is A1i, A2 stands for the J component, that is Y component A2j, and A3 stands for Z component A3k bar. So this is the representation of vector in the parametric form. This is the representation of vector in Cartesian form. So A1, A2, A3 means A1i plus A2j plus A3k. For example, as we had this point P, X, Y and Z, then here vector OP bar, which is the position vector of P, is given by means of R bar, where it can be taken as Xi plus Yj plus Zk. So this is how you represent every point in the space where the rectangular Cartesian system is given with the direction I, j, k, in which all the vectors can be represented by means of like this. But since every vector is given as the component of I bar and j bar and k bar, then we minimize this system instead of Ox, Oy, Oz as only I bar, j bar and k bar right-handed vector triad system with orthogonal unit vectors. We can simply say it is orthogonal unit vector triad system in right-handed or left-handed according to the direction of their rotation in left hand direction, that is in clockwise or anti-clockwise. We can simply say that orthogonal unit vector triad system which is right-handed or left-handed. In this every vector is defined in terms of I, j and k. For example, if orthogonal unit vector triad system is taken, in which we have a vector A is equals to 1, 2, 3 is a Cartesian, that is 1 into I plus 2 into j plus 3 into k. This is the representation of a vector in orthogonal unit vector triad system. Suppose if we have let P be a point with x, y, z, or we will take x1, y1, z1. Then here vector OP bar, which is a position vector of point P, is given as x1i plus y1j plus z1k as its position vector in terms of Cartesians, as it is in terms of position vector as Cartesians. And if this represents x, y and z with I bar along Ox and j bar along y and k bar along z, and if there is a vector that is point P, and this point is say x1, y1, z1, then we'll have this is angle theta, this is angle alpha, and this is angle beta, and this is angle gamma. So employees, we can define the direction cosines of a vector OP bar as x1 by modulus of vector OP and y1 by modulus of vector OP and z1 by modulus of vector OP, where modulus of vector OP is defined as root of x1 square plus y1 square plus z1 square, which is equals to small r, as small r is the distance of the point from origin. So in three-dimensional geometry, distance of a point from origin is root over x1 square plus y1 square plus z1 square. Therefore the direction cosines, that is cos of alpha, is given by x1 by root of x1 square plus y1 square plus z1 square, and cos beta is y1 by root of x1 square plus y1 square plus z1 square, and cos gamma is z1 by root of x1 square plus y1 square plus z1 square. This is how every vector is represented in orthogonal unit vector triad system in Cartesian form. We'll consider certain note points related to the vectors. Say number 1 is unit vectors along the coordinate axis are always say I bar and j bar and k bar. Two vectors may not be equal unless their direction is same. Even though magnitude is different, you cannot say that they are equal. And if two vectors have same initial point, they can be coplanar along with same vectors with same initial point.